as many applications in Python specifically. And then the second textbook is from Open Intro. So it's also an online freely available textbook with the link over here. So this textbook, the applications are in R, but the explanation of the statistics is quite well written. That's why we have also included it here, although we will, for this presentation, mainly focus on Python. Okay. So I'm going to start with the exploratory data analysis. So just briefly for this section, I'm first going to go over just some concepts and giving you a brief overview of statistics, what we are doing, what's exploratory data analysis, why we are doing it, and the types of analysis you can do in that stage. And then we will go over to Python, get our hands dirty a little bit with some code. So first of all, what is statistics? So statistics, we are making sense of numbers. Briefly, we are making informed decisions based on data and what we collected. Then we are organizing and summarizing data in order to be able to draw conclusions. So then the first step in statistical, the concept here is we have a population. So we have a whole collection of objects that we actually want to reach a decision with. But it's impossible to sample or to have a look at the entire population. So therefore, we take a sample from this population, which is, there's many ways to do it, but that's not a rabbit hole we're going in today. So we take a sample from the population, and this is the part of the population that we observe. So we collect data on only a subset, and we're trying to make decisions of the population or represent the population with the sample. So the data that we are collecting is interests, is characteristics that we are interested in of the sample and the population, but we measure it on the sample. So then in the data, a variable is the character, is the what we give a name for the characteristic whose value we are observing. Okay, so this characteristic can take on many forms. So two main categories, it can be either categorical or numerical. So categorical is anything that can be divided into categories, like eye color, marital status, ratings. That's also categorical data. And then numerical data is something that you can measure or count. So it gives you an actual numerical value, like height, weight, temperature, the number of cars, number of pages in a book. That's all examples of numerical data. So then going over to exploratory data analysis. So here we are simplifying large amounts of data in a sensible way. This is not where we are drawing conclusions. We are not reaching conclusions regarding hypotheses. And we are also not trying to infer the characteristics of the population in this step. So in the exploratory data analysis step, we are only presenting quantitative descriptions of the data. So this is the part where you get your data and you dig in and explore exactly what the words say. This is a way of describing the data. And because you need to get a feel of what is in the data, this is the starting point. and the basis of every quantitative analysis. Okay. So then for the two types of data that we had a look at, so categorical data first. Remember, this is like eye color, ratings, etc. The descriptive statistics, or the number way of explaining data, is frequency tables. So these frequency tables are usually just a count of how many observations are in each category. You can also calculate proportions, the proportion of observations in a certain category. Okay. We will do all of this in Python just now. And then the way of visualizing the data, which is a nice way to report data. So first of all, categorical data can be presented in a bar plot, which is something like this, if you can see my mouse. So you can either present it as the count or the proportion of observations in the categories. This is usually directly from the frequency table. And another way is a pie chart, which most are familiar with. Okay. Then if you have multiple categories that you want to summarize in the same bar plot, for instance, there's many ways of doing it. So this is just an example of how a bar plot will look over many categories. So it's either a stacked bar plot, so the two bars are stacked on top of each other, or it can be right next to each other. So this is just some ways of doing the categorical data. Then in numerical data, remember that is anything that we present in numbers. So height, weight, temperature, etc. So here the statistics that we can do, we group that into two groups. So the first, we want to know where on the number line is my data. So that those we call measures of location. So that is like the mean, the median. And then we also have something that we call 5 number summaries, which is a compact way of also describing your data. So the 5 number summary consists of a minimum and a maximum, and then your quartiles. So quartiles is actually divides your data into 4 parts. So these are the partitions of where the data is divided. Okay, so it's your first quartile, which means that, this Q1, that means that 25% of your data is less than this value. Then the Q2, that is also the median, that is your the exact middle of your data. So 50% of the data points are below this value. And then Q3 is your third quartile, which means that 75% of the data is less than that value. Then the other statistics is measures of variability. So this is how spread out is my data. Okay, so that is the standard deviation, and then another way is also the interquartile range. Then these plots or this data can be visualized with either a histogram, a box plot, or a scatter plot. So this is the example of the histogram, the box plot here at the bottom, and then the scatter plot. So the box plot follows from the 5 number summary. So if you look at this, so here where my mouse is now, I hope you can see my mouse, where the line is on the left-hand side, that is the minimum of my data. Then here the box part, so the left-hand side of the box, the edge, that's my first quartile. And then the line in the middle of the box, that's my median, my second quartile. And then my third quartile is on the right edge of the box. And then it extends to somewhere here just after 20%, where that line stops. And then there's also dots. So these dots are outliers in my data. Values that's a lot different than the other values. Okay. So then we are now going over to Python, so more practical exploration of data. So I don't know whom of you remember the Pick and Pay animal cards. So a few years ago, Pick and Pay gave you, every time that you buy, for every 100 or 150 rand, I can't remember, they gave you a packet of 2 or 3 random cards. And then the objective was you can collect an entire set of cards. And then on these cards, they had animals. So these are just examples of the cards that they gave. So it was divided into different categories, the cards, and each category was a different color. For instance, these orange cards was in the category Savannah, which is animals that you get in those type of environments. And then on these cards were also some characteristics like the weight, the height, and then also the vulnerability of the animal. So these are just 2 examples of the category. So it's Savannah and then also succulent Karoo. So there's a data set that I uploaded for you on Canvas. That data set contains the information of all these animal cards. Okay, so let's go over to the Python script. Is it readable, the code? Should I make it a little bit bigger? Okay. Okay, so let's go through this script. So here just at the top, just imported some packages. So we are going to use the pandas package, NumPy, and then matplotlib and seaborn for the plots. So this is just, I'm sure you would have heard it somewhere this week, how we set like a working directory where the files are located on your computer. So obviously this is where it's located on my computer, so you can just change that. So let me run that. So first step, we're going to import the data. So I import the data and it's saved into animals. So you can see here, it is in. So then first, I just want to get some brief characteristics of the data set. So first of all, just obtaining the list of variables. Which variables are included in my data? So if I run this list function, it actually gives all the variables. So I can see numbers. So that's just an index of the animals, which animal it is, in which category. So that was that color of the cards that I showed in the slides. The species, is it a bird, a mammal, reptile, what type species? The age, I presume that's like the maximum age of the animal. What's the weight, the size, the speed of the animal, and the vulnerability index. To obtain the number of observations, we use this dot shape, and then we just extract the first the first value, that's the number of rows, which is the number of observations. And then the number of columns, we just extract the second element in shape, which gives us the number of columns. Okay. So now I know more or less how big my data set is, how many variables there are. And then if I dive right in and I want to make a plot, we are going to draw a histogram for the size of the animal, okay, for the entire data set. So if I run just the Seaborn function, so this histplot function is in Seaborn, where the arguments are just the data and then the variable. So if I just run that, it's displayed over here. This is the plot that it displays. So that is a histogram. You can see that more of the values are located in the lower range of the size. Okay, that's an interesting observation that we can make at this point of the process. And then I'm just going to show it with this plot, but you can change the X and the Y labels. So at this stage, the Y label is count, and if I want to change it to frequency, so this is the process that you follow. So you first save your entire plot into a variable, and then from this variable, you actually set your Y label, whereafter you can show it. So if I run this, you can see my frequency, my Y label is now the frequency. Yeah. Okay. So in some cases, you might want to just update some parts of the data. So if I can show you in the data, if I say here, animals, you can see that my vulnerability is updated, is reported with labels 1, 2, 3, and 4. Okay, so these 1, 2, 3s, and 4s are categories that actually mean something, but in the data, it's just displayed as that. So when we are reporting it or when we are doing analysis on it, we would like to have it in a more understandable way. So we are now going to recode this vulnerability column to actually have labels of certain levels of vulnerability. So for the Pick and Pay animal cards, they didn't give certain vulnerabilities or the categories explicitly. So we just went and picked four categories. Okay, so the first is critically endangered. The second is the animal is vulnerable, then near threatened, and least concern. So for those of you that don't know, is they do categorize animals into these categories. The category, there's finer categories as well for conservation purposes, to know which animals to focus on in conservation. So we are going to recode it. So we are the ones we are going to recode as critically endangered. I'm just going to put the small abbreviation. Okay, so these abbreviations are recognized abbreviations for these categories. Then 2 is going to be vulnerable, 3 near threatened, and 4 least concern. So the way that I did it here is I created a dictionary to say that 1 is critically endangered, 2 vulnerable, and etc. And then when it comes to the actual recoding of it, so I have here, I say we're going to recode the vulnerability column, and we are doing that with this dictionary. So if I just run this part, I should first run this. So if I run this part, you can see that everywhere where there was a 1, it's now a CR for critically endangered. Okay. So a dictionary is actually a very quick way of doing it. And then whatever I did there, I'm saving back into the vulnerability column. Okay. You can also create a new variable for this. Okay. So that is there. So if I have a look now at what's included in my vulnerability column, animals, there you go. It's what I recoded my variable with. So if I want to know which animals are included in the data set, so that is, there's which animal species, which animal species are included. That's a categorical variable. So I'm going to make a frequency table. So if you have a look at what species looks like, you can see that it's bird, mammal, fish. So it is definitely categories. And if I want to create a frequency table from this, I use this value underscore count. And this creates a frequency table. So there's 49 mammals included in this data set, 36 birds, etc. Yeah. So the birds and the mammals are the most. And then, so these are giving me the frequencies. And I did mention briefly before that you can also calculate the proportions. So not only the frequencies. So to get the proportions, you use this normalize equal true function inside the value counts. Okay. So in this case, I saved it into the species underscore proportions as an object, so I can later on retrieve it or use it again. So you can see now in this case, it actually gives me a value between 0 and 1. So the proportion is just calculated as the count divided by the total number. So it's a value between 0. I'm just running this so that I can save the frequency table into species. Okay. Are there any questions so far?
There has been a request that
Yes.
you can change to a light mode.
A light mode.
Yeah, but I think there's some venues where the people also looking on projectors, and then it's
Okay. How do I hide this? I'm not sure.
yeah.
I know where to do it, but I can't reach it.
You might have to exit full screen.
Let me stop sharing, then I'll do it, and then I'll share
Okay.
again.
No, I can read the question for you from the Slack.
Yes, yes.
Yes, so there's a suggestion that you can please change the spider to light mode. It may be easier
Okay.
to view on the data projector instead on the dark mode.
Okay, no, that's perfect. I will.
Then another question, what does map record DI mean?
Okay, I will go through that quickly again.
Thank you. That's all.
I'm just quickly changing my into light mode.
Thank you.
The best one.
Light. There it is.
You have a light option because it's solarized light.
Nee, ek het hom net ja, dis nie wat mos gebeur het nie.
Hmm.
Ja, maar niemand is dit. Do you think that's better? I didn't even knowledge. Okay. I'm
Which
going
one
to
that you select now that you pick? I don't know, I
I
just,
picked the light one.
okay, there's a solarized light.
Does it look different? Oh yeah, that's the one I picked. I'm going to share again and then you can just say if it's better now. Is the lighter theme better?
You're looking on the slide to see the comments.
Okay, give the thumbs up.
Yeah.
That's another suggestion,
Yes.
saying that you can choose spider instead of spider dark when you set the mode.
Spider is working better than I. Because I'm
okay.
in spiders, yeah. So
Okay, let me.
yeah, so just change it to spider, yeah.
No, this one.
Yeah, just make it spider, not spider dog, yeah. That is,
That's the one I was looking
yeah.
for. Okay.
The font is then easier to,
Yes, it does look better. Okay. Is this better now? Perfect. I'm just going to rerun what we had. Okay, so there was a question on this map, right? Okay, so I'll just re-explain this again. So in here, we wanted to recode the vulnerability column. So in our original data, it was 1, 2, 3, and 4. We want to give it more appropriate labels. So have it actually vulnerability categories that is used. So we use a dictionary to say that 1 is referring to critically endangered, the CR. 2 is referring to vulnerable. 3 to near threatened, and 4 least concern. So this is what this line of code says. It's creating a dictionary to say this means this, this means this. Okay. Oh, I had to run that. So that's the dictionary. Then in this, just run it. In this vulnerability column of my data, you can see that it's 1, 2, 3, 4. Okay. So then I use this map argument, this map, and I pass it the dictionary. And then it actually goes and recodes all that entire column. So where there was a 1, they will now be critically endangered, or the CR. Where there was a 2, it will now be VU for vulnerable. So if I run just this, that I can show you, you can see that in the first observation, there was a 1 for the vulnerability. And now, after I did the recoding, it's now CR. And then the second observation was a 2, which in my dictionary refers to vulnerable. And now in my new recoded variable, it is a VU. Does that clarify the question? I see a thumbs up. Okay. So then just before I stopped for a moment, we created frequency tables. So this one using only value counts, that's a frequency table just with the counts for each category. And then I also showed you that you can do proportions in the frequency table as well with this normalize equal true argument. So if I just show again in species, that's what's included. And so that's just our frequency table. And then our proportions looks like that. So it's all values between 0 and 1. If you multiply these with 100, it will give you percentages, but we are only interested in proportions for now. If we want to draw a bar plot, okay, we are using the frequency table now to draw this bar plot. Remember, this is a way of visualizing categorical data. So if we use the function from Seaborn, we use this SNS, the Seaborn dot bar plot. So we use the bar plot function. As the first argument, we want to give it the names of the categories. So how we are fetching it from the frequency table is we say species dot index. So if I just run it here in the console, you will see that actually gives you all the categories included in the frequency table. If I say species dot values, that just gives me an array of all the frequency values. So for the first argument, I pass it all the category names. And as the second argument, I'm giving it the array of values. So if I run this, on the top right-hand side, this is the bar plot. It's automatically arranged such that the category with the highest value, with the highest frequency is first, and then second, third, and it decreases as it goes. Okay. I will show you how to shuffle that order in a moment. So let's say we have this data with all these animal species, and now we want to subset. So we only want the observations where we are considering a bird. So we are extracting all the birds from the data set. So this is what is happening in this line of code. So let's break it down a little bit. So this animals.loc, so that is going to extract only certain observations. Okay. And then in the square brackets, I first give it a condition. That's the condition on which I'm subsetting. So I'm subsetting based on the condition that the species column should be equal to bird. And then it's a comma, and then the second argument I do the colon, saying I want to keep all columns. So this is just subsetting based on the rows, on the observations. Okay, and the condition on which I'm subsetting is that the species should be equal to bird. So if I run this and then save it into a variable called birds, if I look here in my variable explorer, I don't know if I can move. Oh, I can move it. You can see that my birds data frame now have less observations. Okay, so there's 36 observations in there, which is the same as what birds were in my frequency table. I knew there were 36 birds, so I expect the subset to be consisting of 36 rows. Okay, so the subset did work. And now, if I'm creating a frequency table of the vulnerability indices of the birds, so remember I did recalculate, I recoded that variable, so now I'm drawing a frequency table on that. So if I show what birds ability look like. Okay, so it does give me the 4 categories of the vulnerability, and then also how many birds are included in each category. So that's just a repeat of what we did for the animals on species. Okay. And if we draw a bar plot for the vulnerability index, so it's exactly the same. So for the first one, we give it the names. The second one, we give it the values. So this is what our bar plot will look like. So here again, we see that it orders the categories according to which one has had the most, so in a decreasing order. So in this case, least concern at the highest frequency. So that is grouped first. Okay. In categorical data, there's some types of data where the categories have an order and some where it doesn't. Okay. For instance, in marital status, there's no order. It's just categories. In species, there's no order. You can't say that the birds is in front of the mammals. There's no logical reasoning for that. So therefore, the default where it gives it in the decreasing frequencies, that's fine for the species. In the case of vulnerability, there's an order. We can say that least concern, an animal with least concern, is less of a conservational concern than one with vulnerable. And critically endangered is obviously the birds or the animals in desperate need of conservation help. Okay, so there's an actual order of events or of categories. So in that case, just displaying the vulnerability as the default is not necessarily appropriate. So in this case, we are going to order the categories first before we draw the bar plot. So the order of the categories that we wanted in is what we had in our dictionary. So the critically endangered, then the vulnerability, near threatened, and then least concern. So this we are doing with the re-index. So in this re-index, we are doing that on the frequency table, which is this bird's vulnerability. And then we're re-indexing, and in the index, we actually give it the array in the order of the names of the categories. So critically endangered should be first, then vulnerable, then near threatened, then least concerned. In this case, we only had 4 categories, so it's still fine to do it like this. Okay. So if I run this, I'm just gonna, before I save it into the variable, you can see that it did reorder my frequency table in the categories, in the order that I specified it in. Okay. So let me just save it, assign it to a variable. And if we draw the bar plot now on this ordered frequency table, it will order the categories and have it in a more appropriate appearance. Any questions?
Nothing in Slack.
No questions.
There are students that are struggling to access the Python script and the CSV files, the folder, but I don't know if it, because it's a screenshot of its connection error.
Okay.
I'm not sure. Because it says access denied, but yeah. I've not been granted authority to deny access to anybody. So I would not do that in any case, so yeah.
Could you all access the files? Okay, yeah, I don't know what the, so the people in the room where I'm presenting from, they said they could access the files. So I'm not sure what that.
There is
Maybe
somebody
it's-
saying that I keep on getting NIN. And I can see there's a screenshot of the code. It will have CRBUNTLC and then the NIN next to it.
Yes.
What could be the reason? I'm trying to figure it out.
So that is NA values.
Yeah, not yeah.
So I'm not sure if you have made sure that you ran all the code or that the data imported successfully.
Because that might
That,
be
that might
data
be the case.
Then there is a question.
So you're only go by copying that on the transfer line.
The?
So you're copying that file.
No, I just run it. I run it from the file.
Oh, okay. Right, because I think the whole part wants to do that, just make the cost how they are.
Oh yeah, I think that's, yeah, I run it line by line. Yes, yes. So there was a question in the room here about how I'm running the code. So I'm running it line by line. Then no plots are corrupted and all the values do run.
There is a question. How do you re-index if one has more variable, let's say more than 50? Not as straightforward as here.
Yeah, it's not as straightforward as here. I think my idea would be if you can maybe get the categories ordered from the dictionary, or if you have it ordered somewhere. I think if you have 50 categories, you would probably import that data set as well. So I think if you assign it in a clever way, then you can re-index it like that. So this is just an array, if I'm not mistaken. So if you can just get the array in a clever format, you can pass a variable there as well.
Then another question, what code do I write to select the index of CRVUNTLC of the highest value for bird vulnerability?
I'll do max now.
Oh, so it's got to come up. Okay.
I'll do maximum and then you can get the index. I'm sure you will do it with this LOC. If you get the location, if you know where the maximum is. then you can do it. I think you will be able to do it similarly than this line of code where you subset. So you then just subset based on the value should be equal to the maximum. But you can also read that from your frequency table. Okay. So if we go on to the numerical data, if you want to draw a quick summary of your data, you use this describe. Describe. So if I'm running this and I am plotting or executing the summary, it gives me quick summary statistics of my numerical variable. So in this case, we have count, there's mean, which is the measure of location, the standard deviation, and then in this next few, that's my 5-number summary, the median of the minimum, the first quartile, the median, which is this 50% one, the third quartile, and the maximum. So that's my 5-number summary of my size variable. If I want only the average, so you can use this dot mean, so dot mean of my variable, but I can also extract it from my summary. Can also extract it from my summary by saying the summary which I saved that variables in and just extracting the mean. So it gives the same answer. So it's 2 different ways of obtaining the mean. Then the minimum size of the birds. So I use the dot min argument. And I can also extract it from the summary that I obtained with the dot describe. Okay. Similarly, maximum is just dot max. Okay. And then you can also extract it from the summary, gives the same values. So this is how you will get the maximum of, if you can use it on the frequencies as well. And then standard deviation, so that gives us an idea of the variability of my data. So the spread, if I can say it like that. So that's standard deviation. Okay. And I can also extract it directly from my summary. So if I want to visualize this data, so for numerical data, the most popular one is probably a histogram. So from Seaborn, I use this histplot function. I give it the birds, the data. Okay, so now I'm only considering the birds. And I say I want it on the size variable. Okay, so there is my histogram of the size. So it automatically calculates the bins. Okay, but if you go to the help on this histplot function, there is some ways to reallocate or to pick the number of bins. And then another way is the box plot, which is the same syntax as the histplot. You just use this box plot function. And there is my box plot. So you can see the minimum, my middle values, my middle section of the data. And then there's also 2 dots at the end, which indicates outliers. So values that's far out in the data. That might give information, or it might be, in this case, it's birds, it might be a very large bird. Might be mistaking the data. So that is where you will dive deeper. Then if you have a look at the histogram, okay, so the mean that we calculated was 66, which is somewhere there. In this histogram, you can see that more values are located to the left, to the smaller values. And as the values increase, there's less and less and less animals with this size, or with the size. So if the mean is here, is that really representative of where the most values are located? In the case of data that is so skewed as it is here, so this means that the values are concentrated either in the lower range or the upper range, and it spreads out as it goes out, the mean might not give you the exact or an accurate representation of the location. That is where you would rather consider something like a median. So the median we call a robust measure of location. So the median will give you, in this case, just a slightly better representation of where the data is located. Okay. So if I run the median, you'll see that it is 58, which is less or more to the side. Okay. There's only 36 values, so I don't think you'll see the big shift here as good, but that's the gist of it. So skewed data, you'd rather use the median than the mean. In some cases, it will be more or less equal. But then you have more symmetric data. Okay, then the interquartile range. So that is calculated by taking your third quartile minus your first quartile. So in the box plot, it's actually this value minus this value. So the interquartile range can actually translate to what's the range of the values of this box, the middle part of my data. And then as the median is a robust measure of location, the interquartile range is a robust measure of variability or spread. Okay, if I'm saying robust, I'm talking about in terms of outliers. So the median and the interquartile range is not influenced as much on the outliers. So if I run that, that's my interquartile range. Are there any questions up to here before we do the last part? I see someone has raised their hand.
Here's one question here. How do you present this in table form?
In table form.
Yeah. How do you present this in table form?
Okay, so this summary value or this dot describe argument, that actually gives it in a nice table, a table form. If you're going to report it, it's mostly in something, in another software where you're going to write the report and then you can just input the values there. But this dot describe, that gives you a quick way of summarizing everything together. And then from there, you can extract the values if it's needed in further analysis.
Base Python, like base R, many of these, even SAS, typically tables that's presented to you are not looking typically very nice. No. Because the reason they do it is a text output that is for easy copy
Yes.
and pasted in other.
Yes.
Of course, you can use Markdown and those kind of things to generate nicer tables, but
Yes. Yes.
there's another question. Can you describe the interquartile range again?
Okay. Okay. So the interquartile range, so that loosely translates to the middle part of the data. So the middle part of the data, if you look in the box plot, it is this box. It's the actual box of the box and whisker plot. So how you calculate it is by taking the third quartile minus the first quartile, which is, it's basically a range of values there. Don't know if you want to add.
And then can you please explain why the max is at 150 on the box as opposed to 200?
Okay.
For those outliers.
Okay, so the maximum in the data is the 200. But though in the box and whisker plot, outliers are automatically calculated and presented as dots. So this line is actually at some interval that was calculated. There's certain formulas for that I'm not going to dive into much detail here, but that line is then actually called the outlier bound, the upper outlier bound. So any value outside that bound is considered an outlier. Yes.
So with those outliers, do you calculate the Q1, Q2, Q3 after the outliers have been used?
No. So your quartiles are calculated with the outliers in mind. So as I said, the first quartile is that's the value where 25% of your data is less than that quartile. So it actually doesn't take into account the value of the others. It just says, here is 25% of my data is less than that. So it doesn't matter. The outliers doesn't matter there.
So the outliers are still taken into account. We are not omitting outliers from the data set in calculating any of the other measures. They are taken into account. But an advantage of percentiles, median, also the first and third quartiles above, for example, the mean, is that they do not have such a large effect on the value you get for, say, the median compared to a mean.
Yeah. Is that the questions?
Now, there's another one. Is there a function that is used to find outliers of a data set without the use of a box plot?
So I would presume that you would have to calculate the actual bounds, the outlier bounds, and then see which values are outside those bounds from your data sets. That's
So
how I would have done it.
So there are different formulas suggested for outlier detection.
Yeah.
And you even get what they refer to as extreme outliers.
Yeah.
So there are formula available for that. In drawing a box plot, the standard formula applied, and I cannot now remember, I think it's a method by Tukey that gets used, but I cannot even remember the exact formula for that now.
Yeah, there's actually two.
Yeah, there are different ones, but the one used by the box plot function is the standard one that is used typically, and that is the one that could be used. I'm pretty sure you would be able to find functions that's already created for Python that can be used to find for you outliers without going to a graphical display. I cannot think now of any though.
I also thought,
yeah,
I would have just done it, calculate the bounds.
Yeah.
The long way of coding it.
Yeah. And then somebody is saying, I'm still confused about the box plot explanation. So I don't know if you want to.
Okay.
I presume it is the interpretation of the box plot, not the coding.
Okay. Yeah, I also. Okay. So the box plot as it displays here. So that is basically a visual summary of my 5-number summary. Okay. So this left line here, that's my minimum of my data. Okay. In this case, we had outliers. So this upper outlier is my maximum, but the line is drawn at where that outlier upper bound is. Okay. And then the actual box part of the box plot, that is the middle part of my data. So the left bound of this box, that is my first quartile. That means that 25% of my data lie between this part, this value, and the minimum. 25% of my data is in that part. Then this line inside the box plot, that's my median. That is the middle of my data. Okay. And then the right edge of my box plot, that is my third quartile. So that means that 75% of my data lies from this value, which I'm not sure, maybe 85, somewhere there, but below 85 to between 85 and my minimum. Don't know if that answers the question. Or if you want to add something.
No, I don't want to add something, but let me get back to the, I'm also jumping around between the presentation and the Slack, so let me quickly. No, it is. Thank you, well explained.
I'm happy that I answered your question. So then the next part of the code, I'm first we are going to consider 2 variables at the same time, so 2 numerical variables. So if I want to see the relationship between the size of the bird and the weight of the bird, okay, I can draw a scatter plot. So in Seaborn, it's done with this scatter plot function. So I pass it the data as the first argument. So I say it's from birds. And then which is my X variable, which is my Y variable. So in this case, I'm plotting size on the X axis and weight on the Y axis. So if I plot this is my size and my weight. Okay. So if you remember from the box plot, those 2 were outliers. Okay. And if you look here, you see most of the data is here until more or less just after 150. And then you get 175 and 200. And this 200 has a very high weight as well. So if you actually go and look into in the data, this observation is an ostrich, which is a very, very large and very heavy bird. Okay, so just an interesting point there. There's in a plot like this, for these 2 specific variables, because of the outliers, there's not really, you can't really interpret the scatter plot as well. There's also not really a linear relationship in this case. Okay. And if you want to apply something like a linear regression, it won't, because of those outliers, it won't give you appropriate values. Okay. So there's different things that you can do with the data that will shift it a little bit, especially if you have outliers like this. So the first thing that you can do is a log transform. So actually all that you do is you take the log of each variable and you consider that as the variable. So we're going to log transform the size and the weight. And this is a function, the log function from the NumPy package.
The default is base E.
Yes, the default is base E. So if you want the base different, then there's an argument that you can set there. Okay. And so let's see if the original values look like this, where the logged values is a little bit, it's smaller. So if I did a log transform on the size and the weight, and now I draw the scatter plot, okay? So in this case, the variables are separate variables. It's not from data. Then I can just leave out the data argument. Seaborn knows what to do with it, okay? And you can actually see that the outliers are dealt with a little, are not as prominent anymore, and that the data does follow a linear trend. Okay, so this is one way of dealing with outliers. Are there something you want to add on the transformation?
So the log trans is a transformation that is applied to the data, and there are many different transformations for data available. This is, I would say, the most popular transformation used, especially have data that is not symmetric but skewed to get more symmetric, or to, like in this case, where you know that there should be some kind of a relation between size and weight, but as we saw, given the outliers, we couldn't really detect it, and it was non-linear. By applying a log transformation, we are obtaining a linear relation between the logarithmic transformed variables.
Yes, yes. So now we are going to do that a little bit later, but now this data is in a decent form for applying linear regression. So you'll actually get decent results on the log transform data, whereas on the original data, it wouldn't have been the case.
So there are some questions. I don't know, does the log transform remove the outliers completely? No. So we are not removing any data. That is the important thing here. We are not. There are train of thought that sometimes outliers should rather be removed from a data set. So maybe you should rather just remove the asterisk from your data and not consider it. The problem with that is when you have data and there's one of the values that in this case is very large, say for the size, it's because that is a possible observation. And by omitting it, you are now meddling with the data. Transforming the data is not removing the data. You are rescaling the data, basically. So the log transform, as I mentioned, that is one of many transformations available. You get a square root transformation, you get an inverse transformation. Of course, these transformation methods have restrictions. So in the case of a logarithmic transformation, you cannot have negative values. Then the log transformation would not work. But I would say for most statistical applications, the log transformation work quite well.
Yes.
There are generalizations of the log transformation. There's, for example, Box-Cox transformation, which has the log transformation as a special case. That transformation Box-Cox has a parameter that can be estimated. And I know that transformation is also available in Python and in R, for those of you who prefer to work in R, and then other package software packages as well. For us, for what we are looking at here, I think the log transformation is sufficient. Yeah. And then a coding question, how would you change the log to base 2 or base 10? So it's an extra option if you want to.
I think it's just if I remember correctly, I think it's just another argument.
It's a second argument.
The
Yes.
second
And I
argument.
presume it's going to be comma 2 or comma 10. Yes.
Let's say comma 2.
Yeah.
Let's see if it runs. It doesn't run.
Okay.
I can't remember now.
You have to just put it in the right place there, but it should be working.
But I did this.
Okay. Also, let me look.
This one says that maybe I used the wrong function because it says the natural logarithm.
Yeah, I wonder now if in NumPy, the log, I did it.
Yeah.
I was maybe not using the NumPy package. Can't remember now.
So this, okay, so this log function is specifically, just see what is specifically for the natural logarithm, so base E, but there should be then another function.
Yeah. I'm trying to remember now. It should really be, but
There should be.
yeah. So somebody has typed kindly use order equals to.
Order. Let's see.
Thanks for helping
Thank
us.
you. Order must be a string. No,
Is it also no? Okay.
that's also not. So there must be another function.
Yeah.
I can't think off the top of my head right now. What's that function?
Oh, there's a built-in function numpy.log10.
Oh, okay, so that's for log 10.
Yeah, it's just numpy full stop log10. Sorry.
Yeah, so this log function will then use base 10. Doesn't give me that function, so.
And then a question that I was expecting to come, and I hope you can do it, Rene. How can we plot the line of best fit and line equation in a scatter plot?
Okay, so when we do the linear regression, you'll obviously you'll calculate the line of best fit. And then if I remember correctly, you can just so you'll again assign this, what do you call it, this plot to the variable, as we did when we wanted to change the axis labels. Okay, and then I remember it's you just add another layer with the equation of the line. So you're going to plot the line. See if I can. Yeah, that's how I would have done it. Adding a layer.
Yeah. I presume that would be, yeah. Just adding layer like what, for example, R, you would just add an extra bit of code at the bottom.
Yes.
This is also you put the extra code. Then somebody commented numpy.log2 is also a built-in function. So apart from scientific of the base E, the other popular bases for logarithmic transformation 10 and 2. But within science, it's nowadays standard to use base E.
Base E, yes, that's standard. We always use base E.
Yeah. But I have seen some textbooks that still use base 10. I think that's what maybe is get used in school as well. And it might be there
Yeah.
in some colleges or universities. They do continue some courses with
Yes.
base 10.
Yes.
Base 2 is, I think, computer science popular, but you know, within science itself,
Yeah.
basically.
Okay, then just something extra that I wanted to add in was exploring numerical data across different categories. So in our case, we had different species of animals. We had birds, mammals, reptiles. And let's say we want to draw, for instance, this is just one example that I did here, a box plot where for each species separately, but on the same set of axes. Okay. Just if I look at the species, you can see from reptile, insect, fish, amphibian, the number of observations is quite small. Okay, so drawing a box plot on only 2 or 3 observations, Python will do it, but it's not really representative. You need at least a few values. Okay, so I'm only going to do this example on the mammals and the birds. Okay, so first I'm subsetting my big animal data set to contain only birds and mammals. Okay, so remember previously we used this animals.loc function, which we're going to subset, and with the square brackets we first give it a condition. Okay, so in this case, last time we said we subsetted the species and it had to be bird. In this case, it can be either bird or mammal. So we say the species, which is the column, and then dot is in this function, which says it can be either a bird or a mammal. So you're giving it basically an or statement. Bird or mammal. And then after the comma, we again do a colon, because we want to say we want all the columns. Okay, so this subsets the data for only birds and mammals. And if you want to draw a side-by-side box plot, so in Seaborn, if you use this box plot function, if I give it this data, the birds and the mammal data, and I say, okay, I want the numerical variable is size and my categorical variable is species, then it's going to draw a box plot based on the numerical variable for each of the categories. So if I run this, it gives me a nice comparison of the birds and the mammals. Okay. So this is also a quick way to quickly compare numerical data between categories. Because for instance, here you can see that the spread of the birds, it's much less than the spread of the mammals. So you get small mammals like mice, small antelope, but also you get elephants, you get whales, which is quite large mammals. So the spread is much more if you think in a more practical way. So there's a quick way of comparing numerical data. Okay. Any questions? I think according to the program, there's a break at 11.
What is the command for arrange instead of or to subset the data? So is in hyphen or then arrange hyphen?
No, I don't.
No. What is the command for arrange instead of or to subset the data?
No, I don't know if I'm understanding the question.
Okay, so if I understand it, instead of subsetting the data,
Yes.
what is the command to get a range of the data? So it means like you.
Let's say that's it, first 10 observations.
I think that is maybe what's meant to the question. Yes.
So
So you want to extract some of the data, but you don't want to subset according to
a variable.
variable. Yeah.
So if I recall correctly, you can this argument where you give posit the argument or the condition on which it should subset, you can also give it a range of values. Let's say you want the first 10, and it will be 0 to 9. Because in the square brackets, these are the rows that should be subsetted. These are the columns. So you will just give it the array of the number of rows or the row numbers.
Yeah. That is, if I understand the question correctly, because somebody else asked it correctly in terms of in statistics, like we have an interquartile range, we also get a measure of spread or variability just called the range, which is the maximum minus the minimum.
Yes.
And within Python, it will be np dot max of your data minus np dot min of your data. That will give you the range. But that's something different. Yeah, that works
Yeah,
out. What is the maximum value minus the minimum value? Yeah. Okay, so yeah, typical that asks if yes, that is it. And then if you work with dates and want a range between dates.
So dates can be sometimes complicated to work with. So usually in programming languages, there's a certain type of variable dates, which simplifies the way you work with dates. That's best that I can think of. Dates are usually not as easy to work with. Don't know if there's something else, or if you can think of a better.
Just okay. Yeah.
Okay,
Yeah, so there is now a 15-minute break, as I understand, yes.
yes, okay, so that is then all for me. So after the break, Paul will continue with probability and categorical data.